Hi students, this video we are going to look at titration. Okay, so I'm going to show you a video of how titration is being carried out. Okay, before I go there, let's look at some of the apparatus that we will usually use. So this picture over here is the picture of your pipette, right? And then to fill up this pipette, this skinny glassware, you will need a bulb, a pipette bulb over here. Okay, so on this pipette bulb is actually a rubber, right? There are one button A, B, and C, three buttons all together. Okay, so when you press button A, you will squeeze out all the air inside the bulb. Okay, and then when you press button B, you will release the pressure that is being squeezed out, and you put your pipette inside, and it will actually suck up all your pipette while the bulb expands. Okay, and then pressing button C will actually help to release back all your liquid that's in the pipette. Okay, we will look at the video to be clear what is it talking about. Okay, so now we have this titration video, right? And you can see that we will start with the filter funnel and your burette. So burette is this long glassware, and then we have all your solutions. We have a distilled water, we have an indicator, in this case they use phenolphthalein. We have the conical flask, and then we have your pipette bulb, the black one over here. Okay, and your pipette is over here. Okay, so he is going to fill up the pipette with sodium hydroxide. So like I was telling you, there's three buttons. Okay, when he presses the first button, it squeezes the air out. Okay, and then he's going to put the pipette into the sodium hydroxide. So the tip of your pipette touch the sodium hydroxide, and he's going to press another button B. You can see the sodium hydroxide rising above. Okay, there's a faint mark on your pipette that measures exactly 25.0 cm3. Okay, so there is a faint mark. Let's zoom in and we will see. Okay, so this mark is somewhere around here. Okay, it is very faint. So when he suck up more than the mark, and then he let the lower meniscus release it all the way until the mark. And that will be when you have exactly 25.0 cm3. Okay, with this pipette, he's going to release, with this sodium hydroxide in the pipette, he's going to release it into his conical flask. Okay, now he's going to fill up the burette. Right, so the burette is a very long glassware. Usually we will put it on your stool to actually fill it up, otherwise you will not be able to reach it if it is on the bench. Okay, so he's going to fill up the burette with the acid in this case, right? So he's just going to pour in the hydrochloric acid. Okay, so he will actually fill it up to the 0 mark, and then he will add an indicator, in this case phenolphthalein, into the conical flask. Okay, so because the phenolphthalein turned pink in sodium hydroxide, so now it is pink in color. So he mixed it around, and then what is he going to do is he's going to release the acid drop by drop using this tap over here. He's going to release it drop by drop until he sees a permanent color change. So he swirls it until he sees a permanent color change. Right, oh, and then you see that it stops immediately. So he should do it drop by drop until a permanent color change, and then he should take note of the volume of the acid that's added in. Okay, so once there's a permanent color change, it means neutralization has completed. There is no acid, there is no excess alkali in this conical flask. There is only an impurity, which is your indicator, in this case your phenolphthalein. Okay, so he have to carry out titration. You will be carrying out titration in the school lab moving forward. Okay, and then we will look at for the endpoint. So endpoint is where the indicator changes color. So when I add 1 drop of the acid, right, the acid will be in excess. And since the acid is in excess, the phenolphthalein will turn from pink, which is alkaline, to colorless, which is when there's acid. Okay, so endpoint is where the color change. Okay, equivalence point is the region where reagents are mixed in the right proportion. Okay, endpoint we always say is your color change, but equivalence point is when it is in right proportion. Okay, so using this idea over here, right, we will look at the titration graph. Okay, to choose an indicator, to choose suitable indicator for your acid-base titration, color change must coincide with the equivalence point. Okay, so titration graph will look something like this, yeah. I have a strong acid, strong alkali titration graph. Okay, so this is starting from pH 14. This is your alkali inside the conical flask. Okay, I have my indicator inside and it is going to show me pH 14. Okay, so I'm going to add acid drop by drop, drop by drop. Okay, every time I add increasing number of drops of acid, it is still alkaline, right? It's still alkaline, still alkaline, still alkaline until this point exactly. So up to this point, when I add, say, 35 drops, 20 cm cube, right? You notice a sharp drop in the pH value, right? Because what is happening here, at this point, when there's a sharp drop, right, your acid, all the acid that you add in, neutralizes the alkali. Okay, and then if you add 1 more drop over here, it becomes acidic now. So there is excess acid. So pH, right, or titration works this way, right? It will not be a gradual kind of curve, something like this, right? The curve will always see a sharp drop. Okay, so this sharp drop over here, right, at the midpoint where your pH is 7, that is where you will have your endpoint as well as your equivalence point. Okay, so within this box over here, okay, my phenolphthalein changes color at pH, say, 12, based on the graph, yeah? And then the metal orange changes color at about 3. Okay, so you see this sharp drop, if it falls within the color range change, then we can choose both indicators. Okay, so having a strong acid, strong alkali titration, right? You can choose both phenolphthalein and metal orange because both of them, right, the color change will coincide with the equivalence point. Okay, next one we have a strong acid, weak alkali. So example, I'm doing titration against aqueous ammonia. So weak alkali, it starts from lower pH of maybe say 11, 12, okay? And then same thing, is alkaline, is alkaline, is alkaline, is alkaline until the point where neutralization happens. Okay, so around 7 you see there's a sharp drop, neutralization happens, and then this vertical sharp drop is my equivalence point. Okay, the midpoint will be your equivalence point. And now, right, your color change, this vertical line, does not touch the phenolphthalein color change at all. Right, it touches only your metal orange color change. Okay, so for strong acid, weak alkali titration, you can only pick metal orange. Okay, on the reverse, if I have a weak acid, example, ethanoic acid, and a strong alkali, your sodium hydroxide. So same thing, start from pH 7, start from pH 14, and then you will see a sharp drop. Your sharp drop, this will coincide with phenolphthalein's color change, and your equivalence point, which is the midpoint of this vertical line, right, coincides, and you can only use phenolphthalein, you cannot use metal orange. And for weak acid, weak alkali titration, usually we don't do this titration. Okay, there's no suitable indicator. There is no sharp drop. Okay, so just a general recap, right? Methyl orange is acidic when it's red. Endpoint, neutralization point, it is orange. And alkaline when it's yellow. Okay, this is the most common indicator you will use for your O levels. Okay, for acid-alkali reaction, it must be in the right amount. Then the pH will go to 7. Then neutralization will take place, right? So if I'm doing a titration, I'm adding the acid to the conical flask, your sodium hydroxide, right? When I add 1 drop, the pH will still be 14. 2 drops still be 14. 3 drops still be 14. Then if, for example, I add 25 drops, which is equivalent to 25 cm3, then you will see a sharp decrease. Okay, and then that's where neutralization occurs, and 1 more drop, there's excess acid. And the graph will go back all the way down to the bottom where with your strong acid pH.